5.5 Solving polynomials. Let's go to this worksheet. So first, I want to factor completely. If the polynomial is not factorable, write prime. So the first one here, the best way to factor this, since there's 6 terms, and anytime you do 4 more, you want to do it by grouping. So we're going to group the first 3 and the last 3. That's not the only way to group it, but it's the easiest way for now. And in all times, sometimes you have to like rearrange it to make it work. But in this case, we're good. Because if you look at the first 3, they all have an a in common. So you can pull that out. So you have 3x plus 2y minus z. Always bring down the middle sign. And these all have a b in common. 3x plus 2y minus z. Right, now these match. Pull that out. 3x plus 2y minus z. A plus b. So that's factored. Next one. I think if you work, let's look at the first 3. If you do the first 3, does it work? Yes, they all have an x. If you do the last 3, they all have a y. So the first one can pull out an x, and actually a 2x. They all can be factored by 2, so we'll pull out a 2x. And I get, remember when you factor this divide, so you get k, because 2kx divided by 2x, 2x cancel out. 4 divided by 2 is 2m, and then 2nx divided by 2x is just going to be negative n. Goes to the bring elemental sign. These all have a 3 in common, and a y. Remember, factoring is just dividing, so this guy divided by that guy gets me a positive k. This guy divided by this guy gets me a positive 2m. And this guy, positive 3n divided by negative 3, actually gets me a negative n. But look for the rest, these match. Pull that out. And you're left with 2x minus 3y. Something like that. The next one. Now sometimes you gotta rearrange it to make it factor. If I do the first 3 here and the last 3, they actually have nothing in common. There's no x's, no numbers, that doesn't work. If I try to rearrange it, maybe if I do like anything that's fit to the by 3. And then everything else. Can't do anything there either. These are all like not factorable, and this is I factor 3, but nothing else works. This is actually prime. Nothing works. So it's not factorable. They're all that work, just prime. So the next one, let's try to do the first 3 last 3 thing again. Now the first 3 have an x cubed in common. Look at that, they all have an x cubed. And we're left with cubed. Y squared minus 8y plus 16. Bring down the middle sign. What happens on this one? What do they all have in common? They have y's, but how many can we pull out? Y3 is the most you pull out. You always pull out the smallest one. So pull out a y3. Now y5, you took out 3 y's and you had 5 of them, so you only have 2 left. Minus, you had 4, you took out 3, so there's 1 left. And all these are gone. So you get that. Hey, these match. Pull that out. And look what's left over. X cubed plus y cubed. And you think we're done when we're not. Not by a long shot. So first side, this side factors. It's a perfect square. It's y minus 4 times y minus 4. Or y minus 4 squared. That side's done. Perfect squared. This side, that's new to this section, right? X cubed plus 3 cubed, the difference of cubes. The formulas I do give you, they're right here. So this is what you do when it's a positive cubed. A cubed plus b cubed. This is like my a, and this is like my b. So it's going to be the first term by itself plus the second term by itself. First term squared minus the 2 terms multiplied together plus the last term squared. And that's how you factor it, right? All the way down. Right, so you factor it, then you have to factor some more because both of these were not prime. So let's move on. This one, this is a difference of cubes, right? So this is just like a cubed minus b cubed, where my b here would be 2. So use the formula. Again, I will give it to you. It's right here. First term by itself minus the second term by itself. First term squared. This time it's plus. It's same opposite negative. Same opposite plus, sorry. And then you multiply them together, so 2x. And then the last one squared. 2 squared is 4. So there you go. So the formula, I probably should write the formula. It's a minus b a squared minus, well, it's already minus, so plus ab plus b squared. The last one's always a plus. This is my a, this is my b, and I plugged it in. Same thing over here. These are both cubed, right? Cube root of 27 is 3. This is like saying 3z cubed. Cube root of 125 is 5, so it's like 5 cubed. So this is like my a and b again. So the exact same formula, right? So we're going to use this formula. So we have it here. So it's the first by itself, 3z, minus, you follow the sign, whatever it is, 5, times the first one squared. So if I'm going to square this, you can square both of them. So it's become 9z squared, plus, multiply them together, I get 15z, 3z times 5, and then plus the last one squared, 25. And add its factor. Remember, you always do the formula, I will give it to you, just gotta know how to use it. Next one, x cubed and y cubed, like, oh, for the cubes. There's a problem though. 2 and 5 are not cubed. I can't do anything there. This is actually prime. Because 2 and 5 are not cubed. So I can't do anything. Next one. Now, before we start, remember what I said before when we start the factoring review? First thing you always do is look if you can factor out any monomials. These both have a 2 in common. So you can factor out a 2. So you get this. Like that. Now, these are both cubes. So this is like saying 2 times, let's put on the outside, 2g cubed, right? Cube root of 8 is 2. That's a 2. Plus h cubed. This is like my a, this is like my b. Formula we're going to use is this one. A cubed plus b cubed. Again, I will give it to you. It's a plus b. It's always the same. A squared, then opposite. AB, and then plus. So again, I will give you that formula, but it's just the same, opposite plus. So plugging it all in, I have a 2 on the outside. Then on the inside, I have the normal one. Plus. Times that one squared, right? This one squared. So 2g squared is 4g squared. Minus, I need the opposite of what it is. Multiply them together, 2gh. Plus the last one squared. And that's it factored. Next one. First rule again, what do they have in common? They both have an x squared. So I get a to the 6 minus b to the 6. Now you might think that's a difference of cubes. But really, it's a difference of squares. I could write these as squares as basically divided by 2. So it's x squared, a cubed minus b cubed, and a cubed plus b cubed. It's like a difference of squares, right? A squared minus b squared is the same thing as saying a minus b, a plus b. And really what that is a to any number that's even minus b is the same even number. You just do that number divided by 2, blah, blah, blah. So in this case, you think, okay, we're done. You're actually not. Both of these are different of cubes now. Whew. So that is the formula, right? It's a minus b, same. A squared, different. AB plus b squared. Just using the formula. Literally the formula, like it's with a's and b's in it. Do the same thing over here. Just use the formula. So it'll be a plus b. That'll be a squared different minus ab plus b squared. And then we can't forget about the x squared that's on the outside. So you get that. When it's all said done, you get that. That's a mess. Okay, next one. These are both cubes. This is the same thing as saying 2c cubed, right? 2 cubed is 8. And it's the same thing as saying 5d cubed. 5 cubed is 25. So it's just using this formula right here. That's a different square. So it's 2c minus 5d. Then the first one squared, which is 2c, so it's 4c squared. So same different would be plus, and then you multiply them, so 10cd. And then plus the last one squared, 25d squared. And that would be it factored. Okay, now let's go to solving. Solving is more about how to factor things like this was x to the fourth, x squared. We know how to factor these normally, but it doesn't matter. As long as you have something to the n power, some even number. So the best way we say that is x to the 2n. That makes it even. Plus some other number to the n, plus whatever. You could factor it if it factors. x to the n plus or minus something, x to the n plus or minus something. So it always works when it's even. As long as the middle term is half the first term, you're good to go. So like this one here, middle term is half the first term, so just do like normal. What are the factors of negative 10? That gets you negative 3, negative 5, and 2. Right, negative 5 times 2 is negative 10, negative 5 plus 2 is negative 3. So all we do is put the middle term here, x squared, and minus 5, x squared plus 2 equals 0. Now we do got to solve and split each one. So split it, x squared minus 5 equals 0, x squared plus 2 equals 0. So I get x squared equals 5, square root, x equals plus and minus rad 5, x squared equals negative 2, square root, x equals plus and minus I rad 2. I want to point to the nail here. Over here you have two answers, plus and minus. Over here you have two answers, plus and minus. So you have a total of 4 answers. Right? Fundamental theorem of algebra says whatever the power is, that's how many answers you should have. So this is x to the 4th, I should get 4 answers. I got 4 answers. Same thing with the next one, this x to the 4th, I should get 4 answers. So we got to factor it. Well, two things multiply to get 48, but add to get 19. That's a little harder. 16 and 3. And they have to both be negative because the middle term is negative. Negative 16 times 3 is 48. Negative 16 plus 3 is negative 19. That was tough. You had to really think about that one. So let's plug it in. Middle term minus 16. Middle term minus 3 equals 0. Split. X squared minus 16 equals 0. X squared minus 3 equals 0. X squared equals 16. Square root. X equals plus and minus 4. X squared equals 3. Square root. X equals plus and minus rad 3. And again, we get 4 answers, just like we're supposed to. So what's the next one? So here's the thing with the next one. If you look at it and you're like, oh no, I solved that. There's only one x. X cubed equals 64. Take the cube root. X equals 4. That's not wrong. It's part of the answer. But what's wrong about it? What's really wrong about it? I mean, it's not totally wrong, I should say. Is you only have one answer. I should have 3 answers. You're missing 2 of them. So how do we get the 2 we're missing? And that's where this comes in. Technically, we're supposed to factor this. Right? It's the difference of cube. This is x cubed minus 4 cubed. I can factor this. This is x minus 4, x squared multiplied together, plus 4x, plus the last one squared, 16, equals 0. So you factor it. This splits. X minus 4 equals 0, so x equals 4. So like that part's done. How do I solve this? Does it factor? Never. And no, it doesn't. If you're using the difference of cubed formula, it's never going to factor. So the only way to solve that is either quadratic formula or it could be the square. I think most people prefer quadratic formula. This is actually a really good one for complete the square, but I do quadratic formula because most people like. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So it'd be negative 4 squared minus 4 times 1 times 16. So 64 minus 64. 16 minus 6. I can't do math. 4 squared is 16. Like that, this is 1. So I get x equals negative 4 plus or minus 48. 16 minus that is negative 48 actually. Over 2. I can break down negative 48. 2 and 24. 2 and 12. 2 and 6. 2 and 3. Gone, gone, gone. There's a pair of 2's. There's another pair of 2's. What happens when you pull them out, they both go on the outside, the pairs, and the things 3 stays on the inside. So I get 4 rad 3. So my answer here is going to be x equals negative 4 plus or minus 4I rad 3 over 2. Or I want to divide by 2, I can get x equals, divide everything by 2, negative 2 plus or minus 2I rad 3. So those are 2 answers, and then there's my third answer. So I get 3 answers total. Yeah, I know it sucks. Trust me, I know. Next one, same idea. Let me erase some of this. I need some space for this guy. So we're gonna same idea. I'm I'm going to factor it first. So that factors to be, they're both cubes, is 3 cubed. X plus 3, first one squared, multiply them together, plus the last one squared, equals 0. Split it, I get x equals -3, not even going to mess around. This side is not a good one to use a quadratic, to use the square. It's the best because it's an odd number in the middle. Quadratic formula. So let's go through really fast. -3 plus or minus 3 squared minus 4 times 1 times 9 all over 2 times 1. So this is 9 minus 36, which should get me -27. So I get -3 plus or minus -27 over 2. So that's going to be I rad 27. I could break down 27 though. Not scared. That's 3 times 9. That's 3 times 3. Pair of 3s, so 3 rad 3. So x equals -3 plus or minus 3 I rad 3 all over 2. There's nothing I can do there. There's 2 answers, and there's my third answer. Let's move on a little bit. More of the same. Oh, I do a lot of these apparently. So another one. Man. Okay, so the same one that's cubed, that's the same 4 cubed. This will be like my A, my B. So if I'm using the formula, first one by itself, plus the second one by itself, and then the first one squared, so that'll be 16x squared. Opposites, so minus, multiply them, so 4x, plus the last one squared, equals 0. Over here, once I solve it, subtract 1 divided by 4, I get -1/4. Done. Over here, quadratic formula again. I mean, yeah, this one, the square is ugly on this one also. I mean, quadratic formula is kind of ugly on this one. A, B, C, x equals -b, so -4 plus or minus -4 squared minus 4 times 16 times 1 all over 2 times 16. Oh, so pretty. 4, 16 minus 64. So I'm going to get 4 plus or minus square root of -48 again, all over 32. -40 we did earlier. -48 did it earlier. Here we go. Right there. That got me. I erased it. Okay, well, let's get for erasing it. So 2 and 24, 2 and 12, 2 and 6, and 2 and 3. So a pair of 2s. So they're both on the outside. 3 left over, so 4 rad 3. So this becomes 4 plus or minus 4I rad 3 equals a negative over 32. If I want, I could divide everything by 4. Alright, since I could do everything, I could do it. I get 1 plus or minus I rad 3 over 8. So I divided everything by 4. Okay, the next one. Good news about the next one, there's only 2 answers. Woo! Actually, sorry, 4 answers. My mistake. You do the next one, you don't have to do quadratic formula. I mean, you could. It works on the very start. It's a square root at the end. But the next one factors. At least I hope it does. I'm pretty sure it does. We'll apply the first and last one. I get -24x squared to the 4th, sorry. Well, two things multiply get 24, but add to get -5. That'd be 8 and 3. So -8x plus 2 squared plus 3x squared. Now I know it has a bigger number than normal, but when you split it the same way. Just split them evenly. So it's a 4. So you make it 2 and 2. I plug that into the middle. And you can tell it has to match the middle anyway. So I get 4x to the 4th minus 8x squared plus 3x squared minus 6 equals 0. Back-to-back grouping, they both have a 4x squared in common. So I get x squared minus 1. Bring the middle term down plus. These have a 3 in common. Just checking something. This should be a 2. I messed this up. This should be a 2 right here. I was like, it wasn't matching. That's why I stopped and paused. If you divide both of these by 4, that becomes a 2. Sorry about that. This becomes x squared minus 2 also. That's why I paused. I was like, they're not matching. What's going on? Anyway, these now match. Factor it out. X squared minus 2. And what's left over after these are gone? 4x squared plus 3 equals 0. Then we split them. x squared minus 2 equals 0, x squared equals 2, square root, x equals plus or minus rad 2. Over here, so that equals 0, so subtract 3, 4x squared equals negative 3, divide by 4, so x squared equals negative 3/4. Square root, I have an I already because it's negative, so plus or minus I, rad 3 over square root of 4 is 2. So there's my 4 answers. Plus minus rad 2, and plus minus I rad 3 over 2. I know, a lot of work, I know. Last one. A species of animals is introduced to a small island. Suppose the population of the species is represented by this formula right here. Where t is the time in years, determine the population when it becomes 0. So with the population, it's p to be 0. So 0 equals negative t to the 4th plus 9t squared plus 400. So we do everything like we always do. I don't like a negative t to the 4th, so I would move it over. So I get 0 equals, move everything to the opposite side. Right, like, over, I guess technically this side. So just add t, or just change all the different signs. Either way you want to do it. So t to the 4th minus 9t squared minus 400. And the number for if you can figure out the combination of 400 that gets you these two things, it'll work out. Or you can use a calculator. Luckily for me, I have the answers close to me, so I know it's going to be negative 25 and 16. Negative 25 times 16 does equal negative 400, and when you add them up, you get negative 9t squared. So to me that. Plug that in. Or plugging that in for 9t, because 25t, negative 25t squared plus 16t equals that. Now I can factor by grouping. These have a t squared in common. I get t squared minus 25. Bring down the middle sign. Factor out of 16. T squared. Negative 400 divided by 16 is actually negative 25. So these match. So t squared minus 25 times t squared plus 16 equals 0. Split it. T squared equals 25. So t equals plus or minus 5. T squared plus 16 equals 0. T squared equals negative 16. So I'm going to get plus and minus 4i. Now here's the thing though. It's an application problem. When the population becomes 0, remember t is time. So a couple of these answers don't make sense. You can't have negative time, that makes no sense. You can't have imaginary time, these make no sense. The answer is actually just 5. Only one makes sense in context. That's the video.